All right, hello, let's try this out. I'm going to do the review set 3B on page 81 of the book. I'm not going to write the actual questions, so I'm assuming that you're going to have the book next to you while watching this. So let's see. Can't spell. Review set 3B. The point of the video is to show you that you should focus more on all the thoughts that go through your head while you do the questions, rather than focus on getting the right result at the end. I'm not going to check if my results are correct or not. You can have fun doing that, and I might even do some mistakes. But the whole point is to show you all the thoughts that need to go through your mind while actually doing these questions. So let's get started. For question 1a, we have to simplify something, and we could just write it's 4 times the square root of 11 minus 5 times the square root of 11. And here I see two terms with a common factor that is the square root of 11. So a common term like that can be put outside a bracket, and inside the bracket we could just write both the terms without the common factor. And since 4 times 5 is minus 1, we get a square root of 11 multiplied by minus 1, which is the same as minus the square root of 11. 1b, we have to simplify the square root of 32 minus 3 times the square root of 2. And the square root of 32, I see the number 32, and inside my head I think this is 2 times 16. So we have the square root of 2 times 16 minus 3 times the square root of 2. And this is nice because we can do the square root of each factor. And the square root of 16, so this is the square root of 2 times the square root of 16, which is 4. And we subtract 3 times the square root of 2. And then we are in a similar situation as up here. We have the square root of 2 as a common factor, and we can just take 4 and subtract 3, so we get 1 times the square root of 2. Right. Question 1c, we have bracket 7 plus 2 times the square root of 3 multiplied with 5 minus 3 times the square root of 3. And this is just expanding brackets that are multiplied with each other. Since each bracket has two terms, then we get to multiply every term from that bracket with every term from this bracket, and that's going to give us 4 terms in total. So first we have 7 times 5, that's 35. Then we have 7 multiplied with 3 times the square root of 3, and this has to be subtracted because this guy was subtracted. So we get minus 7 times 3 is 21 times the square root of 3. That's it for 7. Then we move to this guy, getting multiplied with 5. That's 2 times the square root of 3 times 5. And I can do the factors in the order that I want. So 2 times 5. Also, this gets added because this guy is added and this guy is added. So 2 times 5 is 10 times the square root of 3. And finally, we get this one times this one. This has to be subtracted since this term is subtracted in this bracket. So we subtract, and then 2 times the square root of 3 multiplied with all this. Again, I can do the factors in the order that I want. So I start by 2 times 3, that's 6, multiplied with the square root of 3 times the square root of 3, that's really just 3. So altogether, we get some integer part, that's the 35 minus 18. That is the kind of thing you can't do while videotaping yourself. So that is something like 17, I guess. And here we can do the same thing with the square root of 3 as our common factor. So we get 10 minus 21, that's minus 11 times the square root of 3. Right. Let's do D as well. So 1D, we have 6 plus 2 times the square root of 2 multiplied with 6 minus 2 times the square root of 2. And the reason I wanted to do this because in this case we have the lovely case of the sum of two terms that gets multiplied with the difference of the exact same two terms. For this we have a rule that says I can just do the square of the first term, that's 36, and then subtract the square of the second term, because the cross squares, or the cross products, this times this and this times this, they're going to cancel out because they're going to be added and subtracted, so no need to worry about that. This term squared is 2 squared, that's 4, times the square root of 2 squared, that's 2. So altogether 36 minus 8, which is 28. Right, let's do 2a. We have to write with an integer denominator, and we get this 2 divided by the square root of 3, and we don't have an integer denominator yet, but there is this trick that we can multiply both numerator and denominator by the same thing, and if we do the square root of 3 both places, then we have 2 times the square root of 3 up here, and down here we get the square root of 3 multiplied with itself. That's just going to be 3. So here we have an integer denominator, and that can get, so if I skip to 2d now, can get really fun if we have 1 over 4 plus the square root of 7. Then the lovely trick is to extend the fraction again, multiply with the same thing, and what always works is to extend with the so-called conjugate of the denominator. So by conjugate we mean that, so let's just do it, we have 1 and we have 4 plus the square root of 7, and we're going to extend with 4 minus the square root of 7 both places. Because then something is going to happen that is the same that happened up here in 1d. In the denominator we are going to have the sum of two terms multiplied with the difference of the two terms, and that's just going to be, so up here we just get 4 minus the square root of 7, and down here we get 4 squared, that's 16, minus the square root of 7 squared, which is 7. So altogether 4 minus the square root of 7 over 9. Right, let's move to 3. Let's do 3a. So m to the power of 9 over m to the power of 5, we can subtract the powers, so that's m to the power of 4. I'm not going to waste any time on 3b, because anything raised to the power 0 is just 1, so 3c, we have 7 times z over w to the power of minus 2. And here we could say, well, that's 7 times z over w, first to the power of minus 1, and then later we can square. That's using the rules of consecutive powers in reverse, so 2 times minus 1 is minus 2, so that's just the same. And then raising to the power minus 1, that's called the reciprocal, and doing reciprocal of a fraction is just turning the fraction upside down. So all of this in here is just going to be w over 7 times z, and we want all of that squared. And then we can do the squaring by squaring the numerator and the denominator separately, so we get w squared over the square of this is going to be 49, that's 7 squared, times z squared. Alright, let's pause this for a minute.